Today, we're going to polish up our interior mapping technique. Let's go. So in order to finish our interior mapping technique, we need to do three things. We've been working on this shader here, which converts our camera vector and our texture coordinates into interior rooms. So the first thing that we need to do is take this shader and convert it into a material function. And we're going to do that in both Unreal and Unity. Once we have that function, we need to first create a nice set of textures that we can use for both the exterior and the interior of the building. And then we need to create a shader that uses the function and the textures together to create a nice building exterior with these interior rooms. So that's what we're going to do. Let's get right into it. The first thing that we need to do is create a new material function. So I'm going to come here to my folders, or my material folder, and I'm going to click and create a material function. And we're going to call this interior cube. So let's open this up. And creating a new material function is pretty easy, especially if you already have the shader that you're going to be using in it. So we're going to go here to our interior mapping shader that we've been working on, and I'm just going to select all of the nodes except for this texture sample node at the end. We're not going to include that in the function because we're going to be doing it outside the function. So I'm just going to hit Control-C and copy all of these nodes. Then we're going to come back to our material function and I'm going to paste the nodes in. So I've copied the nodes that we created in a previous video for how to create interior mapping. And by the way, if you haven't seen the last couple of videos that I've created, you should definitely go back and check those out first. I have a video where I talk about creating cube maps, a video where I talk about creating this interior cube map shader, and then a third video where I focus on creating specifically this noise here that randomizes our rooms. So if you haven't seen those, be sure to go back and check them out. Anyway, so we copied our function in here, and I'm just going to take the result of my last lerp and plug it into my output result. Now for my output result, I'm going to come over here to the settings, and instead of result, I'm going to call this dir, because this is the direction that my vector is pointing coming out of my function, and I'm going to use that to sample my cube map. All right, there's one more thing that I want to expose here, and that is my randomness. So I'm going to right click and pick and type output, and I'm going to add a new function output, and I'm going to output the result of my random noise that we created in last week's video. So this node here creates random noise, and then it gets rounded to either 0 or 1, and I'm going to take that and plug it into this new output result node so that we can use this randomness outside of this material function. This will allow us to just compute this once and be able to use it in here to randomize our rooms, as well as outside for doing something that I'm going to show you in a minute that's actually pretty cool. Okay, so for this output, for the name of this one, I'm going to call it random, just so that we can remember that we're outputting our random noise. Now for sort priority, I'm going to set my main output, my directional output, as 0, and my random is 1. And what that'll do is when I add the function to my shader, this output port will be on top, and this output port will be underneath. All right, there are two more ports that we need to expose in our function. We need to expose our texture coordinates, and we need to expose this value here that controls the number of rooms. So I'm going to right click again and type input, and we're going to pick a function input. So my texture coordinates are a float 2 or a vector 2. And so for this input, I want to set its input type to be a vector 2. And then I'm going to plug that in here in place of my UV coordinates. And then I'm going to take my UV coordinates and plug them into the preview node. And then on my input node, I'm going to check this box here that says use preview value as default. And what that will do is this node here that's plugged into the preview port of the input will be used by default if nothing is plugged into this input port. All right, and then the last thing that I need to do is add a new input port for this static value here. And so I'm going to right click again and type input, and we're going to get another function input. And again, this one is going to be of type vector2 because it's controlling the grid of rooms. In this case, I've got my rooms with 8 across and 8 down. So 8 rooms horizontally and 8 rooms vertically. And I'm going to do the same thing here. So for my default values, I'm actually going to use values of 4 here. And then I'm going to plug this into my multiply instead of my 8 and 8. And we'll check this use preview value as default. So it's going to default to using 4x4 rooms. And then if I plug something into it, I can obviously override that. All right, I need a little bit better names for these. So for this first input, I'm going to type UVs. And for this second input, I'm going to type room count. All right, and that's my function. I'm all done, and I'm ready to start using this function in a shader. So I'm going to come down here to my content drawer again, and I'm going to create a new shader, a new material, and this one is going to be called interior shader. And we'll open that up and then grab our content drawer again. And we want our interior cube material function that we just created. Here's our interior cube material function that we just created. It has these two inputs, UV and room count. And when we dragged it in, you can see, oh, you know what? I need to swap the order of these two. It's not super critical that you do this, but it can be a little cleaner. So for sort priority on the UVs, I'm going to put 0. And then for sort priority of room count, I'm going to put 1. And what that will do is make it so that here in my material function, my UVs are on top and my room count is second. Now let's switch over and I'll show you how to do the same thing in Unity. All right, here we are in Unity. And I'm going to go to my shaders folder and I'm going to right click and pick create shader graph subgraph. So in Unity, a material function is called a subgraph. And I'm going to call this interior cube. And then I'll double click it to open it up. And here we have a new subgraph. Now, first thing we're going to do is create our output. So I'll select this output node here and open up my graph inspector. And I want to have two outputs. One of them is a vector 3 because it's the direction that we're going to use to sample the cube map. And the other one is our random noise, which is also a vector 3. So I'm going to hit this plus here. I'm going to create a new vector 3, and we're going to call this one random. Okay, so I have my new outputs, and now I just need to hook them up. So let's switch back to our test interior mapping. And just like we did in Unreal, I'm going to select all of these nodes and copy them. Make sure not to select the sample cube map node there that we've been using. So I'm going to switch back to my subgraph and maybe zoom out a little bit, and we'll paste these nodes in. And then I'm going to wire the result of my final lerp into my directional output. And I'm going to wire the result of my round into my random output. Okay, so that's it for the outputs. I've got my direction and I've got my random. Now I need to set up my inputs. And to create inputs for subgraphs, in Unity you use the blackboard. So here in the blackboard, I'm going to hit the plus, and we're going to add a vector 2 for our UVs, and a second vector 2 for our room count. And so let's grab these and we'll plug UVs into our multiply, and we'll plug our room count into our multiply as well. Now for the default value for room count, I can hit room count here and then open up my graph inspector, and I want to set the default again to 4 by 4, so 4 rooms across and 4 rooms down. And then we'll need to plug in a value for UVs outside our subgraph. Okay, so the subgraph is done for Unity. Let's go ahead and create a new shader. I'm going to right click and pick create, and you can do this in either URP or HDRP, but I'm going to do HDRP for now. I'll pick shader graph, HDRP, lit shader graph, and we're going to call this interior shader. And I'll open up our interior shader, which currently has nothing in it, and I'm going to add our new interior cube subgraph to it. And now you can see that we've got UVs and room count coming in, and we have our direction and our random coming out. And we're ready to start using this, but we need the textures. We're going to need the textures for both Unreal and for Unity, so let's switch over to Photoshop, and I'll show you the textures that I've created for both the building exterior and the building interior. Okay, so here we are in Photoshop, and this is the first texture that I created. This is the texture that's going to be the exterior of the building. So you can see I made it so that it looks like there are walls and windows. And I have some details here that show what the windows look like when they're not transparent, when you can't see through them. And I'll show you what that's going to do as soon as we get into making the shader. The other thing that I did is I created an alpha channel for this shader. So here's my channels panel. You can just push the little button down here in the corner to make a new channel. And what I did is I made this alpha channel, which will tell the shader what parts of this texture are the exterior of the building and what parts of it are the interior of the building. The white areas being where the glass of the windows is transparent, and then the black areas being where the building is opaque. So you can see I've just kind of used the square select tool here to select these areas, and then I've made these white in the alpha channel so that I can use that data to determine where the windows are transparent and where the building is opaque. All right, so that's my exterior texture, and I went ahead and imported that into Unreal and Unity. And then let's talk about the cube map texture that I'm going to use. So this is the standard cube map texture format here, where we've got our positive X, positive Y, negative Y, and then positive Z, negative Z. And this is the format that we'll use for Unity, like I went over when we talked about cube maps previously. And then for Unreal, because Unreal uses Z up, we need to use a format that's a little bit more scrambly. So you can see that for the positive X and negative X, we've had to rotate these counterclockwise and clockwise. And then positive Y and negative Y, we've had to flip the positive Y upside down. And then positive Z and negative Z can remain as they are. So here's the texture that I created for Unity, and you can see that it matches this format here, where I have the left and the right walls, the top, the ceiling, and the floor, and then I also have front and the back walls here. But for Unreal, I had to rejigger these a little bit so it would match this kind of crazy Unreal format where things are rotated sideways and upside down and all kinds of scawampus. Now notice here that I had to swap the ceiling and the floor with the front and the back. So for the Unity version, the ceiling and the floor are the 3 and the 4 tiles. But for the Unreal version, the ceiling and the floor are the 5 and the 6 tiles. And then I've swapped the front and the back tiles here with those. And the reason for that, again, is because Unreal is using their Z-Up format. Okay, the other thing that I want you to notice about this cube map that I created is that there's no perspective. Each of these walls and the ceiling and the floor is absolutely flat. And the reason for that is because we're not using this cube map in a normal traditional cube map way where the cube represents an infinite environment. We're representing an actual building interior. And so the walls, the ceiling, and the floor, when you make these, they need to be completely flat. Now you can make yours however you'd like. What I did is I just went out and found some random pictures of things that might be on the walls, floors, and ceiling of an office building. So here's a kind of crazy painting and maybe a glass door and some light switches and outlets and clocks and a whiteboard. But you can create yours however you want. Maybe if you were doing the interior of a home, it might look a little bit different. You might have some images of furniture and that, but I wanted mine to be kind of an office building interior. Okay, so now let's take a look at how we can use these textures to create the final shader of our interior mapping. All right, now that we have our textures, we're ready for the fun part. We're gonna create our final interior mapping shader. The first thing that we need to do is import our textures. So I'm gonna come here to our textures folder in Unity and right click and pick import new asset. Then I'm gonna go to the directory where our textures are stored, and we're gonna import our interior cube sample and our windows texture. And the windows texture is probably good to go as is. As I'm looking at the inspector here, I can see that it's set to sRGB, which is correct, and that it's using the input texture alpha. So if we look here, we can see the alpha channel here with the interior of the windows that I created. But the cube map needs a little bit of help. So let's pick our interior cube sample. And I need to set this. You can see that right now it just looks like a big line. And we need to set this so it's actually a cube map. So here under texture shape, I'm going to pick cube. And then for the mapping type, I'm going to pick 6-frame layout cubic environment. And then for the convolution type, I'm going to pick specular glossy, and I'm going to pick fix up edge seams. Now I'm going to come down here and hit apply. And you can see when I do that, instead of it being a long, thin texture, now it shows on this sphere, which means it's a proper cube map. All right, so I'm ready. Sure, I'll just go ahead and drag my window texture in. And for my cube map, I'm going to look for a cube map sampler. So here's a sample cube map node. And then I'm going to select my interior cube map. So now you can see I've got my window texture here and my cube map texture here. So I want to sample my cube map texture with the results of my interior cube subgraph. So I'm going to grab the dir output here and wire that into my incoming dir port on my sample cube map. And I also need some UV coordinates for this. So I'm going to type in UVs and bring in my UV node and connect that up to my input port for UVs. And now you can see I'm getting something that starts looking like an interior. Let's open up our previewer and take a look at what it looks like. If I wire the results of my cube map into my base color, you can see that we have some pretty cool looking interiors, and it's probably a little bit more realistic if I put these on a cube. So now you can see I've got the insides of my office building working pretty well, and you can see that the randomness that we worked on in last week's video is serving to make each of the individual rooms different. It's choosing the front, back, left, or right to use as the sides and the back of the interior of the building. All right, so we've got our interior going on here. Let's work on our exterior of our building. So this is our building exterior windows. we're going to use our same UVs here, but because our windows texture actually has a 2x2 grid of windows, I need to take these UVs and multiply them by 2 to match that grid. So here's my multiply, and I'll just multiply these UVs by 2 and then plug them into our sampler. And now you can see that I have this 4x4 grid here that matches the 4x4 grid that we've already set up for our interior. So if I plug this into our final color, now you can see that I've got an exterior of the building that is also a 4x4 grid of windows. All right, now we're going to add some really interesting effects. I want to make these windows transparent so that you can see the cube through them. And in order to do that, I'm going to use the alpha channel. But I only want to make them slightly transparent. So I'm going to add a multiply and multiply this alpha channel by 0.1, which is going to darken it down quite a bit. And now I'm going to make it so that the windows are less transparent when you see them on an angle. So in order to do that, I need to add a node called the Fresnel effect node. And you can see that what this node does is it creates white on the edges of things and black in the middle, kind of black when it's facing the camera and white when it's facing perpendicular to the camera. So this is the effect that I want, but I actually want the inverse of this. And so I'm going to wire that, or I'm going to pull this out and use a 1- node to invert it. And this is going to make it white in the middle and then black on the edges. And so what this is going to do is it's going to make the windows nice and transparent when we're looking straight at them. But then on the edges of the windows, they're going to be opaque. So I want to adjust this a little bit. I'm going to set my power to 0.1 so that my windows are nice and transparent when I'm looking straight at them. But then as they go around to the edge, that effect is going to fall off. So then I'm going to multiply my windows by that. And this will allow them to be transparent when we're looking at it, but then opaque when we're not. And now I'm going to use that value to lerp or blend between my exterior window texture and my interior cube texture. So let's take my interior cube texture value here and wire it into the B of the lerp. And I've got my exterior wired into the A of the lerp. And then I can take this value here that I've calculated for the alpha, or where the windows are, and plug that into the T of the lerp. So now if I use this and plug this into my base color, we can take a look at the results here. And I don't know if you can actually see it very well, but there's the clock of the building interior. Actually, you know what? I'm going to skip this multiply by -1 for now, just so you can see this a little bit better and you'll be able to see exactly what the interior versus exterior is doing. All right, so now you can see that because I'm blending between my exterior texture and my interior texture, now you can see this interior mapping effect working as it should. So I have the exterior of the building, I have the interior of the building, and as I rotate around the building, you can see that cool parallaxing effect happening on the interior, which gives the illusion that there is actually an interior in here, when it's in fact just a very simple cube. All right, there's one more effect that I want to add to this, and that is I want to add some lights in the building. So some of these rooms are going to be lit up, and some of them are going to be dark. And so in order to do that, we need to use emissive. And so this is what I actually exposed this random port on the interior cube mapping subgraph for, because I want to be able to control which rooms are lit and which ones are not lit, and have that be kind of randomized. And so let's go ahead and do that now. So I'm going to take this random value that I've exposed, and I'm going to add a split node And in this case, we're just going to use the green channel. We don't need all 3 channels of the random noise. We just need one of them. And now I'm going to take the output of my cube map and the output of my windows and multiply that together so that the cube map values are bright where the windows are showing and dark where they're not. And then I'm going to multiply the result of this by the green channel here. Actually, let me show you what this green channel looks like. This is just going to be a couple of exposed cubes. It'll show you like some areas are going to be black and some areas are going to be white. Now I can take these 2 values and multiply them together. My split coming out. And this is going to take some of those windows and make sure that they're on. And some of them will be multiplied by black, which will make them off. And then I'm going to add one more multiply. And this I'm just going to multiply the result by 20 so that the windows that are lit are going to be nice and bright. And you can kind of see that in the preview here. Some of the windows are on and some of them are off. So I'm going to wire this into my emission pin here. And then we'll connect up our base color again. And now we have some of the windows of our interior are lit and some of them are dark. So as we move around here, you can see that it's kind of a randomized thing, which windows are lit and which windows are dark. Okay, I'm just going to spend a minute and clean up our graph so it's a little bit clearer what's going on. And I'll show you what the final graph looks like, and then we'll switch over and I'll show you how to build this in Unreal as well. All right, here's a final look at our graph. If you want to pause the video and use this for reference, you're welcome to. Otherwise, let's move on and I'll show you how to do this in Unreal. All right, here we are in Unreal, and we've got the beginnings of our interior cube shader. Here's our interior cube material function that we created, and we need to bring in our textures. So I'm going to open up our content drawer, and here's our window texture. So I'm just going to grab that and drag it in. And we also need our interior cube map section, or texture. If I search for interior, you can see here's my interior cube map. And I'm going to drag that in as well. Now, the interesting thing, that a difference between Unreal and Unity is Unreal uses the same texture sample node here for an interior cube map as it does for a regular texture. All right, so now that I have my cube map here, I can wire the direction coming out of my interior cube into the UVs of the texture sample. And then if I wire this into my base color, let's take a look at our output. Yeah, now we've got some pretty cool looking building interiors going on. All right, now let's take a look at the building exterior. I can wire that in, and you can see that my windows don't match my my interiors, so I need to add some UV coordinates, and I need to multiply these by 2. And now I can pass this value into my texture sample, and now I've got windows that match the interior of my rooms. So now I need to lerp between my interior and my exterior. So I'm going to wire out here and add a linear interpolate node. And we're going to interpolate between the exterior and the interior. And the value that we're going to use to determine if we should show the interior or the exterior is the alpha channel of the exterior windows. So now if I wire the result of this lerp into my base color, you can see that the exterior is showing where my alpha channel is black, and the interior is showing where my alpha channel is white. Now, just like we did in Unity, there are a couple of things that we can do to improve this. We want to make the windows look a little bit more like glass, and glass is reflective, especially at glancing angles. So let's go ahead and add a Fresnel node in here to simulate that reflectivity. Another thing that we can do is take our alpha channel for where the windows are, and we're gonna take the inverse of our alpha channel, and we're gonna use that for roughness. So our windows are gonna be really smooth, and the exterior of our building is going to be really rough. The other thing that we're gonna do is make our windows a little bit less transparent. So we'll add a multiply here and multiply the outcoming or the output of our alpha channel by 0.1. And that's gonna tone down our alpha channel quite a bit. Actually, let's make it 0.3. And now we're gonna add a Fresnel. And what this Fresnel does is it does the fall off, just like we saw in Unity. So I'm gonna wire up my my vertex normal world space to the normal socket, the output of the Fresnel. And if I wire this into base color, you can see that the Fresnel is like a fall off. It's white on the edges and black in the middle. And I want to invert that. So I'm going to add a 1 minus node. So 1 minus my Fresnel will be white in the middle and then darker on the edges. So now I'm going to take that and multiply it by my alpha channel here, so that my windows will be more opaque on the edges, because that dark on the edge is going to get multiplied by that value of the alpha channel, so that the windows are darkened when they go around to the edges. But one thing I want to do is adjust this Fresnel. My exponent is currently 5, and I'm going to make it 0.1 so that it's only bright here as I'm looking straight at it, but then as I go around to the edges, it's going to be dark. So now if we take a look at this value, you can see that my windows get darker on the edges and they're brighter in the middle. Okay, so now I can use this value as my lerp, and we'll blend between the building exterior and the building interior. So now you can see as I look at the windows at glancing angles, they're opaque, but then as I look at them straight on, they're more transparent. And you can also see a little bit of reflection here as I look at this on the edge. You can see that the windows look more like glass now because I've made their roughness 0, and I've also made them not transparent on the edges, so we get these nice reflections. Okay, just like we did in Unity, we're going to add our one last effect here where we light up some of the rooms and dim some of them down. So I'm going to take the random value coming out of my interior cube here, and we're going to add a component mask to it. And I'm going to take just the green channel for random. We'll take a look at what this looks like. If I wire this in, you can see that some of the cubes are white and some of them are black. So we're going to take the result coming out of our cube map sample here, and we're going to multiply it by this edge fall off value. And then we're going to multiply the result of that by our random mask. And then we're going to take the result of that and brighten it up. I'm just going to multiply it by a static value of 20. And this is going to be our emissive. So I'll wire this into our emissive color and wire this into our base color. And now you can see some of the offices are lit inside and some of them are dark. And that's happening because I'm taking these this random value and multiplying it by the cube sample. And then I'm boosting it so that it's a little bit brighter and passing that into emissive. All right, now there's obviously a whole lot more that we could do with this. We could add normal maps, and we could add a roughness map to the building, and we could kind of turn this into a whole material. But I'm going to leave that as an exercise for you guys. You can make up your own interior textures and your own exterior window textures, and probably end up with something that is a whole lot cooler than mine. But hopefully in this tutorial, I've given you enough information that you can take what I've done here and just really run with it and make some really cool interior cube mapping effects. Let me know down in the comments if you have any questions about this, but I hope this video has been helpful for you and that you can now take what I've done here and make your own building interiors. Well, happy shading, everybody. Have a great week, and we'll see you next time.